Good morning, students. So, as we discussed in yesterday's lecture about the rules for the ray diagrams in mirrors, today we will discuss the ray diagram cases for concave mirror. And one more thing, this is chapter 10, light, reflection and refraction. In yesterday's lecture, by mistake, I wrote here 12, chapter 12. It is not chapter 12, it is chapter 10. तो कल हमने जो तीन चार रूल हमने पढ़े थे, वो रूल कौन से थे मैं एक बार आपको ब्रीफ में रिवाइज करवा देता हूं. द फर्स्ट रूल सेज इफ अ रे ऑफ लाइट इज coming parallel to principal axis, then it will pass through focus after reflection. This is our first rule. The second rule says that if a ray of light passes through focus, it becomes parallel to principal axis after reflection. That is our second rule. The third rule says that if ray of light is coming through center of curvature, it retraces back the same path. That is our third rule. And the fourth rule says if any ray of light, these are the poles, is incident at pole making some angle with the principal axis, reflects back making same angle with the principal axis. That is rule 4. So these are 4 rules which you need to remember. 1, any ray of light coming parallel will pass through focus. Second, any ray of light coming through focus will become parallel after reflection. Any ray of light which is passing through center of curvature will retrace back its path, and any ray of light which is incident at pole will reflect back making same angle with the principal axis. We can have focus and center of curvature points here. So using these 4 rules, we can use any 2 rule depending on the situation, and we can go for and we can start making ray diagrams. So the first case is when we are taking object at infinity. So when we are taking object at infinity, we generally draw the object like this, which extend on the both sides of principal axis, and we can show it for dotted lines representing it is at much distance. So what is the point about object when it is placed at infinity? The rays of light coming from object are parallel to each other. So this is the first ray which is coming parallel. This is your concave mirror, the back side of the mirror, pole, focus, center of curvature. So when light is coming parallel, so we will apply the first rule as we discussed. Parallel ray of light coming, it will pass through the focus. Second, ray of light is also coming parallel to principal axis. After reflection, it will also pass through the focus. So you pay attention here that after reflection, not before reflection. Some students say that, sir, this is the line reflected and this is the ray coming, so here image will form. That is wrong. We are looking for point where rays are meeting after reflection. So first ray after reflection, second ray after reflection. First rule is applied twice, and the rays are meeting at principal focus after reflection. So our image will form at this focus point, and object is placed at infinity. So what are the points about this case? That is case 1. The position of object is infinity or infinite, and position of image is at principal focus, and size of image is highly diminished, or we can also say this point sized. Nature of image. Nature of image is real and inverted. What is this real and inverted? Let me explain. So you are observing that rays of light are actually meeting after reflection. So when the rays of light are actually meeting after reflection, then a real image will form. And when rays of light will appears to meet, then virtual image will form. So in this case, rays of light are actually meeting after reflection, hence real image will form. And you can remember this, that real image is always going to be inverted, because this is point sized image. We cannot distinguish whether the image is inverting actually, but when we will be having the image of some finite size, you will observe that it will invert. So these are the details which you need to remember about this first case. Similarly, we are having second case, in which we are having again concave mirror, but this time our object, this is pole, principal axis, focus, center of curvature, and this time the object is placed at some finite distance, but it is beyond C. Object is beyond C. So case 2 is when your object is placed beyond C. So I can write here position of object. So I can continue same, or okay, I will write position of object is beyond C, and we will find out about where the image will form. Again, applying the rules which we have studied, any ray of light which is going parallel to principal axis, right, will pass through focus after reflection. Now look here, we can apply any second rule out of all remaining 3 rules out of 4. First rule we have already used. Second, we can draw this ray diagram in many ways. So you can have a ray of light passing through center of curvature and retrace back the same path. You can have a ray of light which is passing through focus and then become parallel to principal axis, or you can use the rule of pole. But personally, I will suggest you to use the rule in which ray of light is passing through center of curvature and retraces back same path. While following this rule, the chances of error are minimized, and you will always get your good image between center of focus, between center of curvature and focus. Okay, so ray of light is coming parallel, passing through focus, and ray of light is coming through center of curvature and retraces back. So here your image is formed. If I will represent my object by AB, image is generally represented as A dash, we'll write here, A dash, B dash. So as you can see here very well, if object is erect, then image is inverted. So as I was telling you, that if the rays of light are actually meeting after reflection, then the image formed is real image, and real image is always inverted. So now we can write the position of image here. Position of image is between center of curvature and focus, and size of image is diminished because it is smaller than the size of object. So it is diminished, and nature of image is real and inverted. One more point which we can remember with these diagrams right here, like in this case, magnification is 0. Magnification is defined as size of image divided by size of object. Magnification is defined as size of image divided by size of object. Here size of image is 0, so 0 divided by something is 0. In this case, magnification is going to be magnification. So magnification, it is represented by M. Magnification. So magnification here is always going to be negative. Negative sign is indicating inverted image. So magnification is negative, and the value of magnification is always going to be less than 1 because the size of image is smaller than size of object. So next is your case 3, and we are having object at center of curvature. Now the object is placed at center of curvature. So this is your object. And let me show you the rays of light with different color. Let us say red color. So any ray of light which is coming parallel to principal axis will pass through focus, and any ray of light which is going through focus will pass through principal axis. So here the diagram is little tricky. Yes. So there is a point to note in this diagram, like when you are having your object at center of curvature, after having your first ray of light parallel to the principal axis, you cannot apply the rule of ray of light passing through center of curvature because object itself is at center of curvature. So you cannot apply the rule that ray of light passing through center of curvature and will reach to mirror. So we are left with the two remaining of rules. One is that light can be passed through focus and become parallel after reflection, which I used in this ray diagram, or you can use it is incident at pole and making same angle it will reflect. In this case, your ray diagram will always become at the center of curvature itself. So if this is the AB object, A dash B dash is the image, and we can write the details for this diagram. Object is at center of curvature, and image, position of image is at center of curvature, that is same, and size of image is same as that of object. And about nature of image, nature of image is real and inverted again, as rays of light are actually meeting after reflection, and the magnification here, as the image is of same size as that of object, magnitude of magnification is going to be 1 because it is the ratio of size of image to size of object, and magnification m is going to be negative because image is inverted, and its value is 1 because size of object is always equal to size of image. Similarly, this was the case 3. Similarly, we are having case 4 for concave mirror, case 4 pole, focus and center of curvature, and we are having object in between center of curvature and focus. Let me draw the rays of light again, and this side is the back side of the mirror. I always show them with such dotted lines. So this is your rear side of the mirror. So here we can apply the first rule, a parallel ray of light. So till now you are observing that first rule is same, first step is same, a ray of light which is parallel to principal axis, and this ray of light passes through focus after reflection. The second rule you can apply, a ray of light passing through center of curvature, and you can make it like this. I will extend this ray of light, and the ray of light which is passing through center of curvature. In actual this light will start from this point, will go in this direction, because it is coming from the direction of center of curvature. It will retrace back and meet here. Okay, so as it is meeting here, let me erase some portion of my case 3 diagram so that I can show you. Okay, yeah, this space is good enough. So this is your principal axis, and this is your image. So if AB is your object, then A dash, B dash is your image. Now what you are observing in this ray diagram, as the object is between C and F, the image is beyond C. Not even the image is, not only the image is beyond C, but image is much larger than your size of object. So this is our case 4, in which the position of object is between C and F, and the position of image, its position of object and image. So position of image is beyond C, and size of image is enlarged, because in this case size of image is greater than the size of image is greater than the size of object, so it is enlarged. Nature, as rays of light are actually meeting, is real and inverted. And about magnification, as we know that size of image is greater than size of object, and but it is inverted, so minus sign is for inverted, and because size of image is greater than size of object, so it is going to be greater than 1. So you will understand this when we will do the numericals. Magnification is going to be negative and greater than 1, because size of image is greater than. So there are two cases which are remaining for concave mirror. One, when your object will be taken at focus, and the last sixth case, when your object will be taken between F and P. So these two cases we will discuss in next lecture. Till then you must practice them. These diagrams are very tricky. It may seem that you will draw them at the first attempt in your test or your exam, but it is not the case. You need to do practice for these diagrams, and remember the value of magnification. This will help you in solving the numericals, and you will be cross verified when your magnification will follow these conditions when you will solve the numericals. If we are having any doubt, we are going to have a live class, so you can take any doubt about making these diagrams there. Till then, take care. Bye. Thank you.